Hello, I'm Philip Muggleston, and in this series of videos we're covering the predictive capabilities native to SAP HANA. In this video we continue to focus on time series analysis, in particular exponential smoothing. Last time we saw single exponential smoothing. This time we're going to look at double exponential smoothing. Now you may recall from the last time, when we did single exponential smoothing, we were getting a fit, which is here in gold, which is not really matching the data we were actually seeing in reality. And part of that is because the data we're seeing is trending upwards. It's trending data over time. So a better way of approaching that is to use the double exponential smoothing approach. The difference between single and double is that the double also takes into account trending, as well as the regular classic smoothing. So in order to do that, first thing, if you're not already thinking of it, is to go to the documentation. Every function that we have within the predictive analysis library is well documented in the reference guide, and it's here you'll find the absolute specifics about to access all of the different algorithms available. For example, for time series we have single, double and triple. Exponential smoothing, if we go to double, and we can now see some of the theory behind how it does that calculation. But what's maybe a little bit more relevant for us right now is to just understand how do we call that capability. So what signature table do we need? How do we call it? In fact, we're using the double smooth instead of single smooth. The signature table is actually the same for single, double and triple exponential smoothing. So we can use the ones that we've already created. But again, you get all the details of that, the input data, the raw data, the parameter table and the output table in the documentation. And also notice that when we do double exponential smoothing, we have a couple of new parameters that we can use. We have the beta parameter, which is a smoothing factor like the alpha we already saw, except this is the trending smoothing factor. And we also have a forecast num, which is the number of periods into the future that we want to forecast for. So that's something with trending we're able to do. So having seen that information, what we need to now do is go back to our environment and let's go to where we had the code from before. Now it's up to you how you want to approach doing this, but the types we're using are identical, so we don't really need to recreate those. The signature file we're using is basically can be identical for single exponential smoothing, so we can reuse that. The difference here is that we need to say double smooth. So we're going to put double smooth as we generate this procedure we're going to use. Now you could use the same name for the procedure, however in this case I'm just going to put a D there so that we can actually have a procedure for single, a separate one for double, another one maybe later for triple, so we can call any one of the three at any time. So I'm going to make sure the AFL is the active schema, so I run that, and then I'm going to now create my double exponential smoothing procedure. That's now been done, called pal_ts_d. Now again, very similar to the single exponential smoothing, we can use the same input data with the same parameter and results, just maybe one or two little tweaks. So for example, what we want to do here is include a couple of new values that we add into our table, that beta value, the beta smoothing factor, and also the forecast number of periods. So we'll set up a couple of defaults. Let's run that. But here we need to be careful, make sure we're now running against our application schema. So we'll run that, and let's run these two, insert these two parameters to our parameter table. And then finally we need to call it. And in fact, all we need to do here, as we created one that ends with D for double, we simply just change the name of our procedure. We can use the same input we see in the same results table. But again, that's up to you. That's just the way I've approached it in these examples. So again, using the PAL schema, I'm going to empty out the results table. I'm now going to call the double exponential smoothing algorithm, which now runs. And if we now go back, because it's the same output table, the same view, I can simply refresh this and let's look. This is the fit with single exponential smoothing. Now we're with double. Let's have a look. We get a much better fit. In fact, we can see it fits much closer because the algorithm for double exponential smoothing takes into account that trending. Now, we can also have a look, just maybe tweak some of these parameters. For example, if you want, you could maybe, we started with the beta smoothing factor of 0.1, so a lot of taking into account historical data, but we could maybe increase that maybe to 0.5, where that would allow us to have more relevance to more recent data. And in terms of the forecast, we maybe say we want to go out to 6 periods into the future. So let's just update these two for our second run. Again, we clear out the results table, we run the procedure. Again, it takes a couple of seconds, even against very, very large volumes of data. Look at our results, and this time when we refresh, you see we've had to get maybe even a little better fit, a bit more of a closer fit there, and we can see we've actually got that projected out for 6 periods into the future as we requested, with a forecast underscore num value. So that's another example. Now, I want to just try one other area. We've been looking at cameras, but maybe we want to change our analysis to look at TVs. Now, very simply, if you may remember from a previous video, if we take the item IDs in our input data from 30 to 39, we'll be looking at TVs. So I'm just going to revise that view. So I'll just need to do a quick drop view. So I'm going to drop the view as it already exists. Again, in the PAL schema, let's just be sure we got that right. Okay, now I'm going to recreate this view. Okay, this time we've got a different set of items being used for analysis. So we can come in and clear out the results table, run our analysis. This time we're doing double exponential smoothing, but it's against a different set of products. We can see we get a fairly reasonable fit. However, you may notice that there's something a little bit different about the input data. In fact, for televisions, the input data is not only trending over time, but it's also a little bit more seasonal. It's got some seasonal variation. In fact, every 3 months or so, you see that the values dip a little. So when we've got seasonality, that's where we might want to involve triple exponential smoothing, and that's a subject for the next video in this series.